We'll now continue our discussion of section 2.5, linear inequalities in two variables. We're going to look specifically at a type of example where we are given two linear inequalities separated by the word "and." The word "and" in a linear inequality means that a solution set needs to satisfy both inequalities. So we're going to begin by graphing both of our inequalities. So let's begin with the 5x minus 2y is less than 10. Remember that we have discussed how we want to begin by setting it equal instead of less than. So 5x minus 2y is equal to 10, and we want to do a table of values with at least 2 points. Often you will find your x and y intercepts to be easy points to calculate. So if I plug a 0 in for the x, I am going to have 5 times 0 minus 2 times y is equal to 10. The 5 times 0 will fall out. 2y is equal to 10, or negative 2y is equal to 10. And y would then need to equal negative 5. And if I plug a 0 in for the y, so 5x minus 2 times 0 is equal to 10. The 2 times 0 would go away, leaving me 5x is equal to 10, which would imply that x is equal to 2. So that gives me 2 points that I can use to plot the equation 5x minus 2y is equal to 10. And we know that since this is just a less than and not a less than or equal to, we will plot it with a dashed line. And we'll do that in just a second. All right, let's look at our second equation. Y is less than or equal to x. We're going to do the same thing and replace the less than or equal to with an equal to. We're going to select 2 points that we can use to graph the equation. So I might select the point x is equal to 0 and maybe x is equal to 3. In this equation, x and y are always equal. So if x is 0, y is 0. If x is 3, y is 3. Because it was a less than or equal to, we know it's going to get graphed with a solid line. All right, so let's take our information and let's go to a clean slide and let's look at what this graph is going to look like. All right, so both equations have been drawn for you here, but let's go ahead and make sure that we're clear on how that happened. Our first equation, 5x minus 2y, is less than 10. Remember that we had the points 0, negative 5. So I'm going to plot that. 3, 4, there's 0, negative 5. And we had the point 2, 0. And we had said that that would be a dotted line, and you can see that that is what they did here as well. They did a dotted line. For our other graph, which was y is less than or equal to x, we had the points 0, 0 and the point 3, 3. And we had said that would be a solid line because of the equal to. Now, we know from our previous examples, in order to determine how to shade on these, we need to choose a test point and plug it into the original equation. So let's work on the 5x minus 2y is less than 10 first. For my test point, I'm going to go ahead and use the point 0, 0. It's an easy point, and it sits on the left side of the 5x minus 2y is equal to 10. So let's try that for a test point. I'm going to plug in the 0 for the x, the 0 for the y into the original equation. This becomes 0 minus 0 is less than 10. 0 is less than 10, which it is. And so we know if we get a true statement that 0, 0 should be included in the solution set. So I'm going to shade everything on that side of the dotted line. So that is going to be all of this. Okay, so everything shaded in red is the solution to the first equation. Now, I'm going to do the same thing for the second equation. I'm going to pick a test point. All right, so let's pick the point. Again, let's try to pick something that's kind of easy to plug in. Why don't we select the point 2, 3, 4. Let's select the point 6, 0, which would be right about there. And you can use anything you want as long as it's not on the line. So if I plug in a 6 for the x and a 0 for the y, I get 0 is less than or equal to 6. And so that is also a true statement, which means I want to shade so that 6, 0 is included. So I'm going to shade everything to the right of the solid line. Okay, so that means that everything on this side up to that solid line is going to get shaded. It gets a little messy here as we do this. Okay, so everything shaded in blue is a solution to the solid line to y is less than or equal to x inequality. Now remember that in between these two we had the word and we said that and meant that we had to satisfy both inequalities. And so we look at our picture and we look at the place where the red and the blue intersect. And that area represents the solution to my problem. So that area would be all of this that is shaded in dark blue from the original slide. Okay, and so my solution set would be the part that is shaded in blue from the original slide.